February 16, 1943, Tunisia. The metal case snapped open with a click that seemed too loud in the underground bunker. 5 German radio engineers leaned closer, expecting to see the crude American equipment Berlin had promised them, mass-produced junk from a nation of factory workers who couldn't match German precision. Instead, Klaus Herman stared at 10 perfectly machined quartz crystals lined up like bullets in a magazine. His hands went cold. Each crystal represented 40 hours of skilled German labor. The Americans had installed 10 in a single tank radio, and they'd already built thousands of these tanks. Herman's next words would be carefully recorded. "Gentlemen, I believe we've already lost this war." 2 days earlier, German forces had pushed American troops back 50 miles at Kasserine Pass. It was Germany's first major engagement against United States ground forces, and tactically it looked like a victory. Over 100 American tanks lay destroyed across the Tunisian mountains. But Major Friedrich Weber wasn't celebrating. He commanded a signals intelligence unit with one job: capture enemy radio equipment intact. In a smoking crater east of the pass, his team found what they were looking for: an American M4 Sherman tank turret blown clean off by an 88mm gun. The crew compartment was a wreck, but the radio bay had survived. Weber's men extracted 2 complete radio sets, an SCR-508 for tank communications and an SCR-510 receiver. Both were still mounted in their brackets. The technical manuals were still strapped beside them, barely singed. Weber immediately ordered everything transported to Technical Testing Station 12, hidden in an underground complex beneath Tunis. The equipment arrived on February 16, 1943. Klaus Herman, former chief designer at Telefunken and one of Germany's top radio engineers, assembled his examination team. They'd been told American radios were primitive, outdated designs built by workers who barely understood what they were assembling. The external inspection seemed to confirm this: heavy steel cases, simple controls, nothing sophisticated about the appearance. But when Herman released the latches and lifted the cover, 5 engineers went silent. The interior was unlike anything German doctrine said was possible for mass-produced equipment. Every component inside the American radio was identical to the specifications printed in the manual. No hand adjustments, no technician markings, no variations that would require skilled assembly workers to compensate for manufacturing tolerances. This wasn't equipment built one at a time by craftsmen. This was designed for assembly lines. Hans Schreiber, the team's frequency control specialist, focused on the crystal units. These small components determined which frequencies the radio could use. He expected cheap, low-quality crystals, maybe 1 or 2 at most. He counted 10 precision quartz oscillators, each hermetically sealed in metal holders, each marked with exact frequency specifications. Schreiber removed one crystal and placed it under magnification. The quartz was flawless. The cut was precise to thousandths of a millimeter. The frequency stability would match anything produced in German laboratories after weeks of careful work. He did the calculation twice because the first result seemed impossible. Producing one crystal to these specifications required approximately 40 hours of skilled German technician time using German methods. The Americans had installed 10 in a single tank radio as casually as installing light bulbs. Herman examined the circuit boards while Schreiber studied the crystals. The radio used frequency modulation, FM, instead of amplitude modulation in German equipment. FM was theoretically superior, providing clear communication without static, but it required far more complex circuits and tighter component tolerances. German engineers had discussed FM for military use. They'd rejected it as too expensive and too complicated for field conditions. Yet here was an FM radio, mass-produced, operated by tank crews with minimal training. The circuits included automatic frequency control. German radios required constant manual adjustment as components heated up or batteries weakened.
American radios adjusted themselves. Every assumption about American technical capability was wrong. But the question that kept nagging at Herman was simpler and more terrifying. How many of these radios had the Americans built? The team spent 3 days testing every function. They connected the SCR-508 to power supplies and antennas, then established contact with a monitoring station 20 kilometers away. The FM signal came through perfectly clear, no static, no fading, no interference that plagued German AM communications. When they deliberately started a tank engine nearby to create electrical noise, German radios would become unusable. The American receiver's limiter circuits simply stripped away the interference. The audio remained clean. Range exceeded German equipment by significant margins. Reliability was built into every design choice. The radio could operate from -40 to +60 degrees Celsius without performance degradation. German radios required careful operation within much narrower temperature ranges. The construction quality revealed the deepest divide. Everything was modular. The transmitter, receiver, and power supply were separate units. A tank crew could swap a failed module in minutes without tools or technical knowledge. The damaged unit would go back to a depot for repair or disposal. This approach required enormous industrial capacity. Factories had to produce thousands of spare modules. But it meant American tanks maintained communications under conditions that would leave German vehicles silent for days, while technicians performed delicate field repairs. Herman examined the technical manual. It was printed on quality paper with clear diagrams and step-by-step instructions. The writing assumed operators had minimal technical training. Troubleshooting guides used simple decision trees. Maintenance schedules specified exact replacement intervals rather than relying on operator judgment. The manual revealed as much as the hardware. Americans had accepted that frontline soldiers weren't electronics experts. Instead of training every radio operator for months, they designed equipment that anyone could use by following simple procedures. German radios demanded skilled operators who understood radio theory, could perform field repairs, and possessed technical judgment developed over years. When those operators died, their equipment often became useless. Schreiber finished his analysis of the crystal production requirements. His report included one paragraph that made the room go quiet when he read it aloud. Germany would need a decade to produce the crystals in just the radios they'd already identified in American inventory. The Americans were producing 100,000 military radios every month. German factories running at maximum capacity across all services and equipment types produced 15,000. But raw numbers didn't capture the real gap. American factories used automated testing equipment that checked frequency, power output, and sensitivity in seconds. These testers were themselves sophisticated instruments produced in quantities that allowed every assembly line station to have dedicated test equipment. German factories used manual procedures requiring skilled technicians and minutes per unit. One captured American signal generator became the examination facility's most prized tool. This single instrument, standard equipment in American factories, could generate calibrated signals across the entire radio spectrum. It cost about $300 to manufacture. The equivalent German setup required a room full of separate oscillators, attenuators, and meters, costing thousands of Reichsmarks. Crystal production told the complete story. Germany could produce roughly 200,000 precision crystals annually. Intelligence estimates suggested Americans were manufacturing 30 million per year. They hadn't achieved this through superior German-style craftsmanship. They'd industrialized the entire process. Factories in Chicago, Newark, and Fort Wayne employed thousands of workers, many of them women with no prior technical experience, operating automated grinding machines. Precision measurements used optical comparators and frequency counters, not skilled technicians. Quality control was statistical sampling, not individual inspection. The Americans had transformed laboratory art into an industrial process. Herman's report to Wehrmacht High Command ran over 200 pages. The conclusion was 3 sentences. American radio technology is 5 to 10 years ahead of German capabilities in critical areas. More significantly, American equipment is designed specifically for mass production at scales Germany cannot achieve. Matching American communication capability would require resources equivalent to the entire annual Luftwaffe budget, 30 new specialized factories, and 50,000 trained workers. Germany possesses none of these. The report reached Berlin on February 25, 1943. It was classified top secret and distributed to a handful of senior officers. No new factories were authorized, no programs were initiated. The implications were too devastating to acknowledge publicly. But more American equipment kept falling into German hands. An SCR